All right, 15.1, final learning unit of videos. We're very excited. After this, it's all review. But remember, review is up to you. All right, anyway, the title for this unit is called Sequences and Series. The first one that we're doing is we're doing the sequence. It's a list of numbers that follow a pattern. List of numbers that follow a pattern. So we're going to be finding the pattern, using the pattern, and figuring out the pattern. So here we go. So can you find the seventh term in each of these? So you just have to look at it, decipher a pattern. So this particular one looks like it goes up by 2. So if I do it, this is 1, this is the first term, second, third, fourth, fifth, sixth, seventh. So this is 10, plus 2 is 12, plus 2 is 14. Seventh term. That's it. So the first one that you start at is the first one, and then this is the second, third, fourth, and so on. All right, so take a second and see if you, for the rest of these, see if you can figure out the pattern and find the seventh term. All right, so number 2, it's 21. You added 3 to each one to get to the next. Number 3 here, you multiplied by 3 to get to the next term. So you used the one before and you multiplied, and the seventh term should be 2187. And here you divided by 2 to get to the next term, and that allowed you to find the seventh term to be, to be 0.1875. So then we have a simple formula, like simple, sequences, where A1 is literally the first term. We always use subscripts here, and then so n equals 1 throughout the whole formula. What's nice is if they give you a sub n, the nth element of the sequence, you can just find the term right there. So if I want to find the first term, I just plug in 1, so it's 2 times 1. So here I plugged in 1, so n is 1. So here if I plug in 2 for the second term, 2 times 2, and so on. So a sub 3 would be 6, a sub 4 would be 8, and a sub 5 would be 10, because each one of these, we're simply taking the n and multiplying it by the 2 here. So try that on the next 3. This one, and this one, and we'll see if you got it. All right, so looking at this, I don't know what I'm saying. If we plug in a 1 in for n, the 1 goes there, 2 goes there, in the same spot, and we should get 3 squared, etc. So these are the first 5 terms, 1, 2, 3, 4, 5. This one here, you plug in an n here and here. So whatever this number is goes in these 2 spots. So these 2 should always match. And this 2 always stays the same. So these should be first, second, third, fourth, fifth term, as long as I did my math right. Here, same deal. We're plugging in n here. So we're squaring n every time. So the fifth element would be 5 squared. Now with these, it's really nice because if you want the 15th element, you simply go, oh, well, I plug in 15 for n. So 15 squared is 225. I found the 15th. And same deal for this one. If I want to find the 95th element, it's just 95 squared. 9025. And same deal with this one. You want to find the 48th term. Oh, sorry. If the I got to read the questions even when it's my own paper. If the nth element of the sequence is 48, so that means this sequence, that's 48. So how do I figure out what the term is? So in order to do that, that's basically giving me the y, not the x kind of thing. So we add 4, and 52 equals 2n, divide by 2, and n equals 26. Right, so there's a few ways these can be asked. All right, so for this one, we're talking about, I don't know why it keeps doing this, so I'm going to have to just, all the answers are here already, so that's interesting. I'm going to have to go through this in a, just a visual kind of way. So the way that recursive formulas work, one element is based on one of the previous, and the previous one or more. So the way that this works is just like the ones in the beginning, which seemed very simple. You take the 7 and you add 3 to it. Okay, but if I want to find the 8th element, I need to find the 7th first. And if I want to find the 95th, I'm going to have to go through and find 95, all the ones before 95. So the way that that works is, this is how they do it. So if I say a sub 3 is, 3 is your n, that means n minus 1 is the one before it, so that's the second term. That would have been the second term. And this one would have been the fourth term, because this is n plus 1. So the way that this works, when you think about it, and the n minus 1s tend to confuse me and other people. If you see n minus 1, think the term before. And if you see n plus 1, think of the term after. Okay, so if we're using this above example, you can see that the first term is 7. The first term is 7. So if n was 5, 1, 2, 3, 4, 5, here, that we know that if we want to find the term before it, a sub n minus 1, a sub n minus 1 is simply the term before, so that would be 16. And plus 1 would be the term after, so I would need to add 3 to it to figure that one out. It's the 6th term, so it's the next one, or 22. Okay, so I'm sorry this is kind of weird, but I guess it'll make the video go a little quicker. So this is one way to think about it. Okay, this gets a little bit confusing, so let's just zoom in a little. So if I want to find the first 5 terms of the sequence, if I want to find a sub 2, so I already know a sub 1, they have to give you one of them at least when you're doing recursive. So this is the first one. You need to think about, this is a sub n minus 1. If you want to go crazy and think about it, okay, n is 2, because I'm looking for the second term, I plug a 2 into n, and I get 2 minus 1. So that would make it a sub 1 plus 1. All right? That's confusing. I'm sorry. It's just too much, but if it helps you, and if that's the way you can see it, then you can do it. The alternative is to say, okay, a sub 2. This means the one before. So let's just eliminate this, where we plug in the n. And we say, okay, the one before is 1. The one before 3 is 2. The one before 4 is this one. And the one before 5 is this one. So all we have to do is plug that in. A sub 1 is 5. That goes right in there. A sub 2 is 6. A sub 3 is 8, 7, and so on. So that's the easiest route to take for these. So the sequence for this one, we're just adding 1 to the term before. So if it was 5, next one 6, then 7, then 8, then 9. Okay? It's a very complicated way to say something very, very simple. Okay, so you have to, if you can understand what's actually being said, then it makes it easy. So this is 2 times the one before. 2 times the one before. So the one before here was 1, so it's 2 times 1. The one before here, for 3, the one before 3 was 2. So we plug this one right in here. So this just keeps going in wherever we say the one before. We put the one before in, the term before, the term before. You guys are going to yell at me because you don't know it, but it's pretty straightforward. Try the next one on your own, and we'll see if it looks the same. Okay, for this one, if you look at it, they not only give you, say, a sub n minus 1, but they also give you an n. So you actually have to plug it in just like we did on the front of this paper. So a sub n minus 1, that's where the negative 2 goes in. So anytime you see this, it's the one before that goes in. So negative, okay, I'm writing in. Awesome. So that negative 2 is the one that goes in there. And then here the 6 goes there. Anywhere there's an a sub n minus 1, that's where the term before goes in. Now n is simply this n. So in here it's 2, and here it's 3, here it's 4, and here it's 5. And then you just have to simply do the math. Okay? So those are the answers to this one. This one, I tried to figure out so that I tried to erase, so we'll see how it goes. That's why everything was white a second ago. Okay, to do this one, they're asking this in a slightly different way. They're telling you n plus 1 is that. So what's happening here, if you were looking for, you already have the first term. If I'm looking for a sub 2, that means it's 1 plus 1 is 2. So that means n is 1. They give you that 1 to begin with. So that's just telling you that n is 1. Okay, and if you're thinking a sub 3, that means that n is 2. And so on. And a sub 4, n is, oh, I don't need the equal sign there. This is just a reminder. N equals 3, and a sub 5, n equals 4. So that just helps you here. So this is just telling you, if n is 1, then a sub n, that's a sub 1. Okay, plus 1. Because that's where the 1, for this particular problem, 1 goes in here and here. So a sub 1, that's the one before, so that's 4 plus 1, so that's 5. This one would be a sub 2 plus 2. So the second one, the one right before it, 4 plus 2 is 6, and so on. So it's not 4, 5 plus 2. Awesome. I'm having a good day. I'm having a really good day. 5 plus 2 is 7. So now for this one, I'm adding a sub 3 plus 3. I have to remember what n is. So the one before plus 3 is 10, and the one before plus 4. So that would be 10 plus 4 is 14. So try the other two on the bottom. I'll throw out the answers to you in a sec. Okay, for these, you have to look at it. This is the one before, and this is 2 before. Okay, hopefully you figured that out a little bit. So multiplying the 2 before it together to get 2. So this one, the next one, the 2 before. So this one and this one are where we get these two. And then if we want to multiply the 2 before, I would look at the last two. So be 4 and 2, which would give me 8. And then finally, this one right here, same deal. These two is this one is the term before, and this one is 2 terms before. So that's why they have to give you 2 to start, and that means you only have to find 3. All right, have a good day.